Yeah, it's being a little finicky for some reason. It's not, for some reason it just ended my recording. Okay, we'll leave it. If it works, it works. If it doesn't, then you can always ask me the questions again.
Yep.
Okay, so let's do one more example here. So let's do this one here. We have Fe2, so this is also going to be polyatomic, and there's three of them here. So first, let's look at sulfate, okay? Sulfate, because we know that sulfate has a charge, right?
-2.
Exactly. So let's do SO4, and we have three of them, and we multiply it by the charge. In this case is -2, and then what's the total charge it gives us?
-6.
Very
And
good. Keep going.
iron has 2 atoms, and it's in group 8. So the charge has to be
Yeah, what charge would it need to balance the
yeah,
6 here?
3.
It needs yeah, exactly, a plus
So
3
it would
charge.
be sulfate de fer and then 3 Roman numeral.
Perfect. Why do we have to put a 3 there? Why can't we just assume that it's 3?
Because it's a transition metal.
Exactly. Very good. Very good. So, yeah, sulfate. Sorry. And then, yeah, so you had sulfate. Again, this is going to be the French version, de fer. Okay, and then we gotta say fer is 3. Because it's the iron that we don't know the charge of, right?
Yeah.
Okay, perfect. All right, let's do one more. Maybe you can try this one all by yourself. SN NO3, and there's 4 nitrates. So NO3 is one thing. There's 4 of them, and each one has what charge?
-1.
Perfect.
So
In total,
negative,
we have -4. Very good.
and then so Sn must have a charge of 4 for it to
Exactly.
counterbalance.
We only have one, has a charge of +4.
So it's nitrate de l'étain and then 4 Roman numeral.
I think you got it. Let's see, nitrate, d'étain, and 4. Yeah, perfect. Very good. Very good. Nice. You're doing really good now. You're doing
Yeah.
really good now. At the beginning, it was a little shaky, right? Because it's hard to remember that this guy is all one thing, because it's an ion, and you don't need to change the name, right? Why don't
Yeah.
we need to change the name of this to, why does it stay as nitrat? Why don't we have to change the
Because it's
ending
like
of,
a combined ion.
exactly. We already know that it's an ion because its actual formula is written like this, right? So we don't need to change the name because it's already in the form of an ion.
Yeah.
Very good. All right, all right. Let's do this one by yourself now. And you can type the answer for me.
Yeah, so it's hydroxide de fer.
Yep. And how did you write it? Hydroxyde de fer. You're missing one thing. I'm gonna give you some time to look at it. What are you missing? This whole part, perfect. But there's one part you're missing. Oh, I wrote this wrong. Sorry. Sorry. That's how I write it.
Oh, okay, yeah.
Yeah, sometimes I mess up, but it's actually a good thing because then we realize that, hey, I messed up here. And if you can catch it, that's really good. And if you don't catch it, then you know that, hey, I made this mistake, so you're gonna avoid the mistake, right? So it's actually sometimes good that I mess up. I don't do it on purpose, but it's good.
3.
3 here?
Yep.
Bingo. Good job. Very good. All right, we're gonna go the other way now. I'm gonna give you carbonate de potassium, potassium, oops, and you will give me the formula for it.
Okay.
And yeah, we have to put the 3 here because it's a transition metal, right?
So it's
K6 SO3. So try that one again. So we know that carbonate, I'll give you some tips. You know that carbonate is CO3, right?
oh, okay. I thought it was CO and then
And we know that
brackets 3.
potassium is, and this has a 2 minus, sorry.
Yeah.
And we know that this is K, so try it again.
Okay.
K2, So you have K2CO3.
Yeah.
Why is it K2? And why does CO3 not need anything?
Um, CO3 has a charge of -2, so -2 times 1 is -2, and then potassium has a charge of +1, and so in order for the in order for it to counterbalance, it must have two atoms. So potassium has two atoms, and carbonate has one.
Amazing. Perfect. Perfect. Very good. I'm going to give you a couple more examples now, okay? In this one, there's two parts to this question. First, I want you to tell me what is the name. I'm sorry. First, I want you to tell me what is the name. Or sorry, I'm going to give it to you. Nitrat diplôme. So first, I'm going to tell you what is the name. And then second part, so first part, formula. And then the second part, sorry, is a number of atoms. And atoms is each individual. So in this case, how many PB do we have? How many N's do we have? And how many O3s, sorry, O's do we have? Okay, so first let's do the formula part. And once you get that right, we can check the next part, okay? So give that a try.
Nitrate has a charge of -2,
-1.
-1.
Yeah, good question. PB4NO3. Mm, 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 mm. Try that again. So this is what you have, right? PB4NO3.
Yep,
So you're saying that there has to be four leads or four
yep.
plomb, and there has to be one NO3.
Oh,
Yeah, there's something wrong here. Try it again. I'll let you do it again. I want you to try with no help again. And if you're really not sure, then we'll look it up again. And always follow the same process that I gave you, where we check do the charges counterbalance, right? Sorry, somebody's at my door. I'm sorry, somebody was at my door.
Oh,
Do you have your answer yet, or are you still trying?
still trying. I
Okay,
got
no problem. Take your time.
4, 3, 3. Yep. So I got PB 4 in brackets, and then 3 on the outside, and then nitrate, and then 4.
Okay, so this is what you have right now. PB, you said 4, then a 3, and then an NO3
Yeah.
with a 4, right?
So, uh,
But if you see, this doesn't really make sense because you're saying you have 4 PBs, 4 leads, and you're multiplying that by 3. How can you have, you're not really able to have, that means you're saying you have 12 PBs.
yeah,
Does that make sense?
yeah.
Okay. And how much charge does a lead have?
Uh,
4, right?
it's
According to
yeah,
this. So you're saying that it has a charge of plus
oh,
48,
48.
and then we look at NO3, and you said there's 4 of them. We know 4 NO3s will have a charge um, of 1. Each one has a charge of 1. So you're saying that's minus 4. So do you see how it doesn't
No,
counterbalance these
yeah,
two?
that doesn't make any sense.
Yeah. So do you want to give it a try? Or do you want me to help you
Yeah,
with
I
the answer?
forgot that the 4 is the Roman
Yeah,
numeral.
4
Yeah, I
is the
forgot it's the
Roman.
charge. I thought it was the number of atoms.
Yeah, it's always the charge. Okay, okay, good. So do you want to give it another try by yourself?
Yeah.
Okay, go for it.
Okay, I got it.
PB4. Oh, okay, new one. Again, you don't need to put PB4 here, okay? You don't need to put the charge here. Does that make sense? So this is
Okay.
what you have right now.
Yeah.
NO3 with a 4. You don't
Yeah.
need to put the charge here. If you put something here, it makes me think that there's 4
Um,
PBs, right?
okay, yeah. So just PB and then NO3 and then
Exactly. PB, NO3, and then what do we need? How many NO3s do you
4.
have? 4, yeah. This
Yeah.
number always tells you how many you have. It never says the charge is not part of the equation. You know why
Yeah.
that is?
This is the yeah, because this is the number of no, wait, this is the charge
The reason we don't need to know is because we know that NO3 always has a charge of
of negative
-1,
1.
right? So we can calculate the charge of PB.
So it's just going to be 1 times 4, which is 4.
Which is 1 times 4. Yeah, exactly.
Yeah. And then uh, for NO3, NO3 has a charge of negative 1, so negative 1 times 4 is negative 4. So negative 4 and positive 4 cancel out.
Yep, exactly. Exactly.
And
Okay.
so the number of atoms
Yeah, now can you
for
try that? So how
oxygen is
many?
12. The number of atoms for nitrogen is 1, and the number of atoms for plum is 1.
Yeah, so you have these two, right? What about nitrogen? Remember when I told you this
Oh,
4
yeah,
goes
4.
to everybody here? 4.
Nitrogen has 4 atoms.
Perfect. Good. Very good. Yeah, so that was a big thing for you, is knowing that this, you don't need
Yeah.
to put it into the formula because we can always calculate it, right? All right, let me give you one more. Let's give you phosphate. Hopefully you have this one in your thing. If you don't, let me know. De strontium. Try that one. Did you put in the chat? Hey, did you put it in the chat? Your answer?
Um, I lost connection.
Oh, okay. Sorry. So yeah, whenever you're ready, you can put it in the... Okay, perfect. You got it. So you put SR3. Yeah, this is really good. Good. You're improving very fast. And then can you tell me the number of atoms for each one of them?
Yeah. So for oxygen, it's uh 8,
Yes.
and then for phosphorus, it's 2, and then yeah, and then for SR, it's 3.
Yeah, for strontium, it's 3. Phosphorus 2. Why is it phosphorus not 1?
Um, because it has a charge of neg.
Not the phosphorus, right? We don't need to know about the charge
Oh,
for
okay.
phosphorus. So
Oh
why?
yeah,
What
phosphorus
is
has a
it?
charge.
You don't need to talk about the charge.
I mean, it
Why
has
would it have
2
2?
atoms because yeah, it applies to
Everything, right? Just
phosphorus.
like in math, when you do 2 times 1
Yeah,
plus 2, for example, the 2 can go here and it
yeah,
can go
like the
here.
distributive property.
Exactly. It's the same thing in chemistry. Good job. Okay, so the next thing we're going to do is we're going to explore the different types of reactions. Okay. And so in reactions, we have the left side and the right side. Do you know what they're called?
Um, I forgot.
So on the left side, we have les réactifs or
Oh yeah,
reactants.
yeah. Reactives and products.
Yeah, les réactifs
Yeah,
and les produits.
and it's important to balance chemical reactions. Um,
Exactly.
but why why are some like why can't we balance some chemical reactions?
Why can we can
Like why
balance all
can't
of them? We can
we
balance
can't
all of
balance all of them?
Yes, all of them you can balance because um you can't make something out of nothing, right?
Okay,
So the number of atoms you have on the left side always has to equal the number of atoms you have on the right side,
okay,
right? They can always be balanced, um, but sometimes they're already balanced. Maybe that's what you were talking about. Sometimes they're already
yeah.
balanced, so we don't have to do
Because
anything.
I know because like according to like the law of mass conservation, like both sides have to be balanced.
Exactly.
But there's like some cases where like they're not balanced, like we can't balance them. Are there or like
No, they're always going to be balanced
okay,
because, like you said, right? Law of conservation of mass.
yeah,
We can't just like if you're reacting hydrogen and oxygen, you can't just lose oxygen somewhere, or you can't just lose hydrogen somewhere,
yeah,
right? Okay, so I'm gonna give you a basic one like that. I'm gonna have H2, some number of H2, and some number of O2, and they're gonna react to create water.
yeah.
Can you balance this? So let's balance this one together. So the first thing that I see is I'm going to look at the oxygen. Usually I leave the hydrogens at the end, but I'm going to look at the oxygen first, okay?
So there's 2 oxygens and there's 1 oxygen on the right.
Exactly.
So in order for that to be balanced, there must be 2 oxygens on the right.
Yeah, so we need to put a 2 here,
Yeah,
but
and
then what does
then
that do
put
to the hydrogens?
yeah. So now we have 4 hydrogens. So put a 2 on the left for hydrogen.
Exactly.
That's 4 hydrogens, and then 2 oxygens. Yeah, same thing on the right. So that's correct. So you can just put 1 or 102.
Exactly. Yeah,
Yeah.
we just leave it blank because we don't want to create
Okay.
any confusion, right? If it's not necessary, then we usually don't put it. Okay, so I have the next one, NaCl2, create salt, table salt, Na3. Can you balance this one? Just tell me what numbers need to go in these places.
2 on the right, and then 2 sodium on the left.
Okay, so let's see. You're saying a 2 here, nothing here, and a 2 here.
Yep.
Let's see, chlorine, this 2 applies to everybody, so there's going to be 2 chlorine, 2 chlorine. Good. This 2 applies to everybody, so there's going to be 2 sodium, 2 sodium. Good. Okay, try this one next. This is another basic one.
So 2 magnesium, and then 2 on the right.
Exactly. Perfect. All right. Now I'm going to give you some harder examples. We're going to go BaCl. By the way, since we're moving on from uh, like the naming of polyatomic ions and like their reactions, do you have any questions about the thing that we did before? I forgot to ask.
Um, no, but I have a question on something else, which are like the Lewis diagrams for ionic compounds.
Yeah, what's your question about that? Do you want to do some examples or?
Yeah.
Okay, cool. Let's do that. Let's do that. All right. I'm gonna get that set up, but do you want to try this example first while I get that set up?
Yeah. Um,
So this one's a little harder, but I'm just gonna.
okay. So it's B. So it would be 2 NaCl on the
Two.
right.
Okay. And is that all you need?
Uh, yeah.
Exactly. Good. All right. So you're asking about the Lewis diagrams. So they're not too complicated. You should be able to do them. Let's do an example with CaCl2. Okay. So here, let's look at what would the Lewis for calcium look like on its own, and what would the Lewis for chlorine look like on its own?
So there would be 2 valence electrons for calcium
Exactly.
and 1 valence electron for chlorine. And we need to transfer.
Exactly. So we need
There has to
two.
be 2 chlorines. So
Exactly. So, and then this guy, oops, one, two, three, four, five, seven, right? Does that make
yeah.
sense? Good. So I'll do this here, and I'll do this here. And so we need to
So
take
calcium
this.
needs to transfer 1 electron to chlorine, and then there needs to be another chlorine, so then calcium can transfer 1 more electron.
Perfect. Good. And then what that ends up looking like is this.
Is CaCl2.
Yep. And what charge would calcium have here?
Uh, -2.
-2?
Oh
It's
wait.
getting rid, right? So
Wait. So
how?
losing electrons. So +2.
Very good. And then we're going to redraw chlorine. How many valence electrons would chlorine have here?
It's gaining an electron, so it'd have a charge of -1.
Good. And how many valence electrons would it have?
7, 8.
8, yeah. And what was the charge you said?
-1.
Exactly. So I'll put a negative there. And I need to do the same thing on the other side, right? Because we needed 2, right? And that's what it ends up looking like. Does that make
Okay.
sense?
Yeah.
Do
So
you want to do one more example, or do you want to move on? What do you think?
I have a question.
Yep.
So on my test, I had to draw like a Lewis diagram for an ionic compound, but I didn't get it right because like the ionic compound like no matter how many times I kept transferring like the valence electrons, it still wouldn't like form like a stable octet. So I
Hmm.
had to keep doing it, and I didn't really know how to like write the chemical formula, but I forget what the question was. So if I remember the question, then I'll come back to it.
Yeah, perfect. If you have a question like that, I actually think you will know how to do it now because you've already done so many examples, right?
Yeah.
But if you get that question, so go through your notes, right? To this week, I'll give you some questions myself. But what you should do is you should go through some of your own notes that you
Okay.
had. And by notes, I mean don't just read them. Do the
Yeah.
questions that were given, right?
Okay. Yeah.
Then what you can do, a lot of the time you can search them up, the answer up online, right? And then you can find whether you did it correct. And if what you did online and what you're seeing what you tried is not the same, you could just send it to me.
Okay.
Does that make sense?
Yeah.
Okay, cool. I'm gonna give you a lot more practice. I have the whole website with a bunch of practice questions. They're in English though, so I'm gonna like help you with that. I'm gonna transfer it to French
Okay.
for you. Okay, but do you want to do another Lewis diagram, or do you think you're good?
I think I'm good for now.
Okay, cool. So let's try this next one. Okay, so we're gonna go back to it. But yeah, all you have to do for Lewis diagrams is you have to make sure you do these few things. You put the charge. Oh, when I highlight over it, it kind of disappears, but you have to put the charge. Okay? And then the other thing is you have to write what are the valence electrons. So like I did here. Does that make sense?
Yeah.
Okay, cool. Do you like math for the most part? Or like, is that like is that a subject you like or a subject you don't like?
No, I love math. Math is pretty fun.
Okay, so then that's really good because balancing chemical equations is just math, right?
Yeah. Yeah.
So you'll probably like that part more. And you're right, like the distributive property thing that you were talking about before, like that's very good to hear because that's exactly what's balancing chemical equations,
Yeah.
a good
Just
chunk of it
applying
is.
the term to like each term in the bracket.
Exactly, exactly. Good job. So, you did really well with the last question. You were able to get it like fully. So I'm just gonna give you another hard one, okay?
And so like when I have like bigger numbers when I'm like balancing chemical equations, do I just like simplify them? Like
Yes, yes.
yeah.
When we get to an example like that, I will show you. The only thing you can't simplify is the actual compound. So for example, if you had if you had C2H6 plus O2, and that becomes CO2 plus H2, you can try balancing this, but the thing you cannot do is change this guy into something else. You cannot change it into CH3 because
Okay.
that's a whole different compound. Even though
Yeah.
all you can do is divide here by 2 and divide here by 6, you can't do that because that's changing the compound. Now,
Okay.
if you had something like a 2 here and a 4 here, and those were the only things you did, there's a chance that you can simplify a little bit.
Yeah. You
Uh,
just can't change the number of atoms because that changes like the chemical properties of the compound.
Exactly, exactly. Like imagine here, I just changed the number of hydrogen to, uh, or the number of oxygen, I made it 2, right? I can't do that because now it's a
Yeah.
new compound. That's not water anymore.
That's not water at all.
Yeah, exactly. You know what
It's
that
dangerous.
is? It's hydrogen peroxide. Have you heard of that
Yeah, there's
before?
a chemistry joke about that.
Yeah, right? Yeah, exactly. So you can't do that. Okay, so try balancing this one. It's a little bit harder, but I
So
want
this
you to go for it because you seem to be really good at these.
So 3 hydrogen on the right.
Oh, you already starting?
Yeah,
Okay, cool. What do you have for me?
3 hydrogen on the right.
So do I need to put a 3 here? I'm gonna leave these blanks right here. You just tell me what numbers should fit in each of these blanks. So like 1122, 3344, you know what I mean?
Yep.
So what number should I have?
So uh, that wait, leave that as is,
Okay,
and
so
then for
1.
yeah 1, and then for H2O added 3.
Oh, for H2O, sorry.
Yeah, 3 there, and then 3O2. Yep, and 3O. Wait, no, I made a mistake there.
No
Uh,
problem. Do you want to solve this on your paper? Then when you're done, you can just tell me.
yeah,
It's usually easier that way.
yeah.
That's why I figured. I was like, "Oh, okay, that's you're going a little bit too fast, right? It's better if you solve it on your paper, then you try and compare everything."
Can you write the
Oh,
question?
yeah. Sorry. And what you want to do, this is what I want you to do, okay? At the end of your question, I want you to tell me how many atoms of each thing you have. And if it's the same on the left side as it is on the right side, then you probably did it correctly. This one's a little bit hard. I'm gonna try it too. So, can I show you something?
Yeah,
So take a look here, okay? First thing I see is that I have an uneven amount of
of oxygen.
oxygens, right?
Yeah,
So let's try and balance the oxygens first. Here I have 2 oxygens, right? So
yeah,
I'm gonna call it R for reactants, and I'm gonna call it P for products. So let's look at the oxygen first. Here I have 2, right?
and then
And here I have
um, 3.
3. So I need to multiply this by 2. That way it becomes an even number, 4,
So
because you can never
there's
get it
4
to be equal.
oxygens.
Then I need to put a 2 here, right? So that I have 4 as well.
Yeah,
Okay.
but now you have 5 on.
Now let's look at the carbon.
No, now you have 4.
I have an even number here of carbon, right?
Yep.
Uneven number here, so I need to put a 2. Now let's look at the carbon. Carbons are balanced, right?
Yeah.
But the oxygens are no longer balanced anymore, right? Because I have 4
4,
and you
and
have
then
6.
6. So
Yeah,
put
so let's
3,
put a
oh
3.
2.
Good.
And then, you have um, 6 oxygens. And then for hydrogens, you have 6.
Yeah. So can I give you another tip here?
Yeah.
See how oxygen is by itself here?
Yeah.
We are better off doing oxygen at the end because oxygen can be modulated the easiest out of everybody. Does that make sense?
Yeah.
Does that make sense what I'm trying to say? Like it can be changed the easiest?
Yeah. Yeah.
Yeah. So now let's look at the hydrogen. 6 here, right? But only 2 here, right? Or 4 now, right?
Yep.
So I need them to be common. I can put a 3 here and that'll make them common, right?
Okay. Yeah.
But the
But then there'd be
problem, yeah,
3
it's not even,
oxygens.
right?
Yeah.
So I can multiply this by 2, that'll make 12, and then I can multiply this by 6, which is now an even number,
12. Now
right?
you
So
have
now our hydrogens are balanced.
10
Now
oxygens.
sorry, our hydrogens are balanced, right? Let's not look
Yeah.
at the oxygens yet. Okay, oxygen is by itself, so let's leave that to the end. Let's look at the carbons next. There's 4 carbons here, right?
Yeah.
But I only have 2 here, so what should I put here? If there's 4 at the top and there's only 2 here, or now
So
1,
2.
so I'll put a 4 exactly.
Oh.
Well, there was 2 here before, you just needed to
Oh,
double
okay.
it. Yeah, yeah,
Oh,
yeah.
yeah,
So
that
don't
makes
worry.
sense.
Yeah, yeah.
Yeah.
I think you had the idea there.
4 carbon,
Okay, so let's see.
8 oxygen.
We have 12 hydrogens, 12 hydrogens, 4 carbons, 4 carbons. Now we can just do the oxygens freely, right? So how
Yeah.
many oxygens do we have in this bottom row?
So we have 14 oxygens.
Yeah, 4, 8 here, and then 6 there, so 14. So all we need to do here is put what number?
7.
There you go. Do you see how it's easier if you leave the
Yeah.
singles to the end? Okay,
Okay.
perfect.
Yeah. That's
Yeah.
a good trick.
I wanted you to struggle. Like the reason I didn't show you at the beginning is because I want you to struggle a little bit, and then you're
Yeah.
gonna be like, hey,
And then you
okay,
can
I
just
see. Yeah, right. Then
divide
you're
that by a factor of 2 and get 7.
exactly. Then you're gonna see the easier way, and you're gonna be like, okay, now I will remember that because I struggled a lot the first time, so it's gonna be easier this next
Yeah.
time. Okay, cool. You ready for another example, or do you have any questions?
Yeah. A similar example to this.
Okay, cool. You want a similar example to that one? Okay, cool. Let me find one. So you want a tougher one?
Yeah.
Okay.
And yeah, this can be simple. This can't be simplified.
No, I can't. Yeah, 7 cannot be simplified. And most of
Yep.
the time, if you do it the way I'm telling you here, it won't be simplified. Like, as in, like, you won't need to simplify it. Because you're always gonna leave the most, like, independent, I call it, the most independent one, you're gonna leave that always till the end. Right? So you're gonna be okay. Um, okay. I'm just looking now. Trying to find some good examples for you. Do you want to write this example down or do you have it already?
Yeah, I have the simple example written down.
Okay, cool. I'm going to give you one again, but this time it's a distributive one, just because I want to make sure you have those down.
It's like a polyatomic
Exactly. Do you know what this is called? Do you remember what this is called?
nitrate.
Yep, nitrate. So, nitrate de plomb. Are you able to tell what type of plomb this is off the top of your head or no?
Uh,
While I write it down, that can be your practice. So if we look right here, we know nitrate has a charge of what? -1, right? So in total, it's going to be a charge of -2.
the -2 and plum.
And plomb
There's one plum, so it
is
must have a
1.
charge of 2.
Yep, +2. So this is going to be plomb 2, lead 2. Nitrate de plomb 2, right?
Yeah.
Okay, so this one right here is going to be the last example that we do today, I think. I'll see if we, no, I don't think we have any more. This will be the last example. What you're going to do here is you're going to balance. Number one, you're going to balance. And then number two, you're going to tell me in words, what is this equation? And this should be a very good example of what we've done today. Okay, go ahead and give it a try.
What happened? Can you give me like, can I come inside the water? Sure. What happened? Who? Who me? Mommy? Where's the brother? Can I come inside the water? Sure, for water only. For water only. Then I'll do my studies. So it's 2K 903
Sorry, what were your numbers here?
2 for so 2 for the last one for on the products side.
So just tell me like from left to right,
Oh, okay.
like from here. So what would this one be?
1
Okay,
2
two,
1 2.
perfect. Okay, let's see. So on this side, I have 1 PB. So I'm gonna split it like this. Let's do this. I have 1 here, right? Let's look
Yep.
at the right side. I also have 1. Next, let's look at the nitrogens. I have 2. Here, I also have 2 because this a 2 applies to everybody. Good. Next, let's look at the oxygens. I have 6.
Oh wait, isn't there? No, wait, no, never mind.
Yep,
There's
6
not
here.
six. There's no 6 nitrogen, so that was. So then add a 2 on. No wait, add
As of now,
3.
you're good, right? Do you see that? One,
Yeah.
2, 6. Does that make sense? Because this 2 applies to the nitrogen
Yeah.
and to the potassium and to the O3. So as of now, you're good. How many potassium do you have on the left side?
Uh, 2.
And on the right side, because this 2 applies to everybody, how many do you have?
2.
2. Finally, I think we're the iodide, or iodure, right, in French? We
It's
gotta
2
remember to say
iodine.
the French names too, because your test is in French. 2, right?
Yep.
Perfect. So, good job. You balanced it. I'm gonna try and find some more examples. I'm gonna start making a worksheet for you, but by the time, can you please tell me what is this in words?
Ah, yeah. Uh, this is nitrates de plomb
Can
de.
you write them down all on your paper or and then put them in the chat, please? So I make sure your spelling is correct too, because that's an important part. and try and make sure your spelling is good. If anybody needs the Roman numerals, like the charge, that's good. Okay. So I'm just finishing up. I'm creating a test for you, and it has basically like all of the stuff that we did. So what I'd like you to do is after this, take like a good break, take some time, if you want to do some review, and then you can try and do this test that I gave you. I'm gonna send it by email, okay? Are you still able to hear me? Is your connection still up?
Yep.
Okay, perfect.
This is the answer.
And do you have a printer at home?
Yeah, I do.
Okay, cool.
Yeah, I can print out the questions.
Okay, perfect. Sorry, are you done with this question yet or no?
Yep.
Cool. And the other thing I wanted to ask, do you have Microsoft Word? Do you know or no? I can
Uh,
send it as a PDF if that's easier.
okay, yeah, I do have Microsoft.
Okay, so I'm gonna send this as, I'll send it as a PDF. It's probably easier. I would say print it out. If you really can't print it out, then that's okay. But
Okay.
I think best would be to print it out because then it feels like a real test, right?
Yeah, I have a printer so I can print it out.
Perfect. Yeah, that's usually the best. Okay. And sorry, you said you have your answer?
Yep.
Okay. So what's your answer?
I wrote in the chat. It's
Okay, I can see that. So you said
Nitrate.
nitrate de plomb, and it's plomb 2. Good. Nitrate de plomb, and very good for putting the Roman numeral. That's good. Then you said iodio de potassium. Perfect. Sium. Then you said iodio de plomb 2. Very good that you said it again. And then you said nitrate de potassium with no Roman numerals because it's in group 1. Perfect. Good job. This is very good. Remember at the beginning you were having a little bit of trouble on like whether you should put the Roman numerals and how much it
Yeah,
is. But
like distinguish.
now you're very good. Very good. Good job. You should be really proud of yourself. I'm proud of you. In like an hour and a half you covered, like in school, they would
Yeah,
take like 3 days to teach this.
yeah.
And you did it
In
in an hour and a
physics is a
half, right?
yeah,
And the reason I can do it in an hour and a half is because you stay listening and you're very engaged and you anytime you make a mistake, you try and learn from it, right?
yeah.
So I'm very proud. Good job. Okay, did you have any more questions?
No.
Okay, so I sent you the test. What I want you to do, take a break right now, go relax a little bit. It's nice out, so maybe go outside. And then you're gonna print this test out. You're gonna do some problems. You can do it today or tomorrow, because I know you have a day off tomorrow. And when you're done, send me a photo, and I'm gonna send you back the answers, and then you can check how well you did on the test, like
Okay.
what your score was, basically.
Okay.
Okay, perfect. So the only other things we still have to go over, I think, I'm gonna let you do the chemical reactions yourself because we
Are
talked about it.
also distinguishing between ionic and covalent.
Yeah, we can do that. Yeah, I think now that you know Ionic so well, it's going to be easy for you, but still, we can do
Yeah,
that.
ionic is just non-metal and metal, and covalent is two non-metals.
Yeah, perfect. Yeah, you got it, right? And because I showed you how you can figure out which one's a metal, which one is not a metal, I think you're pretty good at that.
Yep.
So the only thing I think we have left is acids and bases, and then just a like big review from beginning.
Yeah.
Okay, cool. And then again, if you have any questions, you always can let me know. You can always message me, right?
Yeah.
Okay, perfect. Any other questions?
No. No.